Welcome to In 5 Minutes. We will now discuss basic FM demodulators which are used in the process of demodulation of received FM signal. There are four very important and basic FM demodulators that are used in many practical FM receivers. We will first discuss the concept behind FM demodulation, which is the common principle on which all the four demodulators work. So the very first demodulator will be the simplest demodulator which will implement that concept of FM demodulation. The remaining demodulators will also implement the same concept, but they will be the improved version of the first FM demodulator. So in case of FM demodulation, we take the FM signal and we give it to a circuit which is called FM to AM converter. So we need a circuit which will convert FM signal to AM signal. The input will be FM signal, but the output will be AM signal. In simple words, on the input side, we have changes taking place in frequency. So we have changes in frequency, and this changes in frequency represent nothing but the information. What we should have on the output side is the changes in amplitude. Now it is irrespective of whether frequencies are changing or not. My main aim through this process is to convert the presence of information which is in the frequency to now presence of information in the amplitude. The frequency of the output AM may still be varying, and hence it may not be perfect AM, but it is AM in the sense that now we have also obtained the amplitude variations as per the amplitude of the modulating signal. So in very simple representation, let's say if you have an FM signal where frequency is first increasing and then decreasing, on the output side, when the frequency is increasing, the amplitude should increase, and when the frequency is decreasing, the amplitude should decrease. So this is what it should happen on the output side. Now the frequency of the output signal might be similar to the input signal, that means first increasing, first decreasing, but if you observe carefully, we have got the changes in the amplitude also. Now why this was done? This was done for a simple reason that once you have got AM out of FM, then we know that we have already done the demodulation of AM signal. We can simply use a very famous and very simple basic circuit of envelope detector. So you have to use envelope detector and you can get your original modulating signal back. So this is the basic principle in the FM demodulation process. You convert FM to AM first, and because now there are variations in the amplitude, I can give it to an envelope detector. It will detect the envelope which will represent my modulating signal. But for this whole process to take place perfectly, it becomes very important that conversion from FM to AM is perfect. Now when I say perfect, it simply means that this conversion from FM to AM has to be as linear as possible. That means if the frequencies are increasing, in the same proportion the amplitude should increase, and as the frequencies are decreasing, in the same proportion the amplitude should decrease. So only when FM to AM conversion is linear, the final modulating signal, because see, modulating signal will be proportional to amplitude variations of AM, and amplitude variations, if only they are proportional to the frequency of the input signal, then I can say that because frequency is proportional to original m of t, my modulating signal, that is output of the envelope detector, will be similar to the original modulating signal m of t. No doubt that modulating signal at the output of envelope detector will be proportional to the amplitudes of the input signal. But if these amplitudes are not linearly proportional to the frequency variations of the input FM signal, in that case, this AM signal will not perfectly represent the original modulating signal. And in that case, the demodulated signal will be distorted and not exactly similar to the original modulating signal. And hence, when we say that we will go from one circuit to the second circuit and we'll see that the second circuit is the improved version, As we go from first to the second and second to the third FM demodulator, we will see that we basically improve the linearity of this conversion process, because otherwise the whole principle of FM demodulation is very simple. You convert FM to AM, and once you have got AM, then there is no differentiation between FM demodulators. All you have to do is use envelope detector. So this envelope detection part will be common in all the modulators. We have to see how FM to AM conversion is obtained and how it is improved as we go from first to second and third FM demodulators. So with that, let us start with the first FM demodulator, which is called single slope detector.